Hi everyone, welcome to part 2 of how to set up your Haas robot package. I'm Corey Sullivan, and in this video we'll be setting up safety zones for our robot. Safety zones are used to ensure your robot stays within a specified boundary box to help limit the possibilities of a crash. With that said, it is still possible to cause damage to your machine or operator, even with DCS safety zones enabled, so you should still always follow proper safety protocols. The first thing we are going to do is take measurements of our desired work zone. We will need to ensure that our robot is installed aligned to the machine and fence. If the robot is not aligned to the fence and machine, the work zone we are going to set will also not be aligned. The work zone is referenced and measured from the center of the J2 axis of the robot. We can use one surface and one edge on J2 in order to get to the center of the axis. Surface A, the flat on the side of the joint, and surface B, the edge of the round part. If using the flat from surface A, we will add 4.5 inches or 114 millimeters. And if using surface B, we will add 2.5 or 63.5 millimeters to our measurements to get closer to the center of J2. Jog the J1 robot axis so that it is at 90 degrees, 0 degrees, or negative 90 degrees to align surfaces A and B with your fence and machine. Here I have a piece of paper with our coordinate system printed on it to help visualize it while taking our measurements. I'll place it like this to match the orientation of our user frame parts table we set up in the previous video, since we want our work zone to be oriented the same way. If we were to use the world frame for our work zone box would be tilted at 30 degrees because our robot is mounted at 30 degrees. Now we'll need to measure the distances to the corners of our work zone. All dimensions will need to be in millimeters, but I will measure in inches and convert them to millimeters later. First, I'll measure the distance from surface A of J2 to the fence opposite of the machine. In my case, this distance is 40 inches. Then I will add the 4.5 inches to get to the center of J2 for a total of 44.5 inches. Then I will convert this to 1,130 millimeters and subtract 120 millimeters to keep the arm a minimum of 120 millimeters away from the fence. This will make my final X negative point negative 1,010 millimeters. Now I'll measure the distance from the surface B of J2 to the fence in the Y positive direction. In my setup, from surface B to the fence is 38 inches. Now I'll add the 2.5 inches to get to the center of J2 to get 40.5 inches and convert this to 1,028 millimeters. Again, I'll subtract the recommended 120 millimeters clearance to get a final Y positive value of 908 millimeters. To get our X positive value, I'll measure from surface A to the door. Then from the door, past the work holding, then add 4.5 inches to get from surface A to the center of J2. In my setup, my X positive value is 762 millimeters. For the Y negative value, I'll measure from surface B to the edge of the door opening, then add the 2.5 inches to get to the center of J2. For my setup, Y negative is negative 597 millimeters. For the Z positive and negative values, we'll measure from the center of J2 to the floor, and from the center of J2 to the top of the machine for values of 762 millimeters and negative 1,041 millimeters. Now we will need to set up our work zones by logging into the HMI Pendent. To do this, you will need to connect a computer to your machine through Ethernet. Open the front door of your robot controller. Mounted to the door, there is a large yellow housing with 2 Ethernet ports underneath it. Unplug the Ethernet cable in port 1 and replace it with the Ethernet cable connected to your computer. Alternatively, you could unplug the Ethernet cable going into your Haas robot electrical interface box and plug it into your computer. Click the Windows icon at the bottom left of your screen and select Settings. Then click on Network and Internet, then Ethernet, then change adapter options. Right-click the Ethernet connection that is connected to the machine and select Properties. Enter an admin username and password at the prompt, then double-click Internet Protocol version 4. Select Use the following IP address. Then enter 10.72.65.83 for IP address. 255.255.255.0 for subnet mask, and 10.72.65.77 for default gateway, and click OK. On your computer, open your web browser and type 10.72.65.82 into the address bar and press enter. You will now be logged in to the HMI Pendent. Click on Navigate Pendent, then Menu and Setup. Then click Type, Frames, and then Other User Frame. Click on User Frame 9 and then click Detail. Now we are going to create a user frame to be used for setting our work zone. The user frames we created in the Haas control in the previous video can't be used here, but we will create a new one identical to the parts table frame in the former video using the direct entry method. To do this, click on W and type in -30 and press enter. Then click on R and type in 180 and press enter. How you set up this frame will depend on how your robot is set up and mounted, so be sure to see part 1 of this video series where user frames are explained. Now that we have our user frame set up, and we know the diagonal corner points of our work zone, let's start creating our work zone. Navigate to the DCS menu by going back to the main Pendent page and click Jogging Pendent. Press Menu, and then 0 Next, and then 6 System. Enable the pendant using the on-off button at the top right, and then press Type 9 DCS. Then click 10 User Frame and press Enter. Select the second 0 under the number column list. A confirmation question will appear at the bottom of the screen. Press Yes to confirm the change. You should see your W and P values change to what we input earlier. Select the second 0 under the number column list and press 9. Now press Previous to go back to the DCS menu. Click 5 Cartesian Position Check and press Enter. Then click on number 1 and press Enter again. Enable the position check by clicking 2 Enable/Disable, then clicking Choice at the bottom, and then clicking Enable on the pop-up. Change method type to Work Zone Diagonal by clicking that row and then clicking Choice at the bottom and selecting 1, Working Zone Diagonal. Target Model 1 should be Robot Model, and Target Model 2 and 3 should be disabled. You can select Robot Model as Target Model 1 by clicking Choice at the bottom and then selecting Robot Model. Set Base Frame to User Frame 9 so that our work zone references this frame that we created earlier. For point 1 and point 2, enter the measurements we recorded earlier. These will be the diagonal points of the work zone box. Our point 1 will be X, -1010, Y, +908, and Z, +762. Our point 2 will be X, +762, Y, -597, and Z, -1041. Now highlight Stop Type and click Choice at the bottom, and change this to Speed Check 1. Next, we will set the allowed speed for the robot to move when it is outside of our newly created work zone. Click on Speed Check and press Enter. Click on Limit 1 and enter 20 to set our speed limit when the robot is outside of our work zone to 20 millimeters a second. Now set the delay time to 0 milliseconds and permissible distance to 0. Now that we've set this, the robot will alarm out whenever it leaves the work zone at a speed over 20 millimeters a second to prevent a crash. Click on Previous at the bottom to go back to the previous menu and click on Use Stop Position Prediction. Then click Choice at the bottom and select Yes. Now let's go back to the main DCS screen by pressing Previous 2 times. Now we will apply all of the changes we made in the DCS menu. Any DCS section that was changed will show a red change next to it. Press apply at the bottom and enter 1111 for the master code. This will take you to another menu that will show you the changes made in the DCS menu since the last time they were applied. Press OK if all changes are correct. The red changed fields will now be yellow pending fields, indicating that they will be changed after cycling power. Now close the HMI Pendent window and cycle power on the robot controller, waiting 5 seconds before powering it back on. Setup of the work zone is now complete. If any part of the robot leaves the work zone at a speed greater than 20 millimeters a second, it will alarm. Now that our work zone is set up, let's go to the 4D graphics section to visualize our work zone in relation to the robot. Access the jogging HMI Pendent and navigate to Menu, Next, then 4D graphics. Here you will see your robot virtually on the HMI Pendent in its current position. To see the DCS work zone we just created, click on Visible on the bottom bar. You might need to click the right arrow to see this. A new menu will be displayed in the top left of the 4D display. Click on 4D DCS display. It will turn a shade of blue to signify that it is on. You will see a box appear if your DCS zone is enabled and set up. Verify that the work zone that appears is surrounding your robot. If the box is red, that means that the part of the robot is outside of the work zone. If the box is green, your robot is inside of the work zone. The robot is displayed in real time here, so you can watch this on your laptop or computer while you jog the robot around. Our work zone will appear angled since we are offset at 30 degrees to compensate for the 30 degrees our robot is mounted at. Now let's verify that our work zone is set up properly. To do this, we will jog the robot outside of our defined work zone at a rate higher than 20 millimeters a second. Click Jog panel at the bottom right of the iPendent window. This will bring up a pop-up for jogging the robot using the iPendent. First, press the reset key to reset any alarms. Now, click Shift to virtually hold down the Shift key. The Shift key needs to be held down while jogging the robot. Now you can jog the robot using the X, Y, Z, W, P, and R, or J1 through J6 keys. To change between jogging methods, click the coordinate key. Now let's jog the robot outside of the work zone at a speed higher than 20 millimeters a second. If the box turned red on the 4D display and the alarm was triggered, your work zone is set up correctly. Reset the alarms, then jog the robot back into the work zone at a rate slower than 20 millimeters a second so you don't set off the alarm again. And that's it. Our DCS safe zones are now set up. We'll see you in the next video where we'll set up our parts table on the template tab.